GSM presents. The Geological Society of Minnesota is happy to present Meteorites, the History and Mystery of Raining Rocks by Mr. Craig Zliman. Mr. Zliman is a citizen scientist meteorite hunter, educator, and owner of Minnesota Meteorites, MNM LLC. MNM is now the largest commercial cutting, curation, and restoration company on the planet. They have the newest and most advanced precision cutting equipment to work on some of the rarest and most valuable rocks known to humans. You may visit their website at https://www.mnmeteorites.com. Mr. Zliman's company partners with any number of universities, museums, and collectors, including NASA, the Smithsonian, Chicago Field Museum, Arizona State University, and many others to procure, protect, sample, and sell the rarest space rocks known. Today's presentation is split into 3 sections: the main presentation, questions, and an up-close view of many of the meteorites that Mr. Zliman brought to the seminar. We hope you enjoy.
Well, thank you. First, thank you everybody for coming on the nicest day of the year. I was kind of joking. I thought there was going to be 6 people. We'll just have a little conversation instead of having to do a presentation. Can I just ask how many people saw the last show I did? This was pre-COVID in the other building. I'm just trying to gauge. All right. So
I'm so good we came back.
This will be different. Even if you saw the last one, this won't look anything like that. Okay. Thank you. So I'm just trying to gauge. With a group this small, it's not difficult to do more of a dialogue than a presentation, but since we have a fair number of new people, we'll kind of run through the whole thing. But I've had several people coming up and wanting to handle the meteorites and look at the meteorites, which will happen at the end of the show. So I will try to talk less, because I'm by far the least interesting thing in the room, and give you more time to come up and ask questions. We will do a Q&A, and then you're all going to be invited up to come and hold some of the pieces and look at the pieces. I've got a microscope here that has a piece of halite in the meteorite. There's only one of 3 meteorites that have halite. It's salt, and it's stained purple from radiation, so you can come up and take a look at that. I also have, I believe, the largest Minnesota meteorite collection in private hands over on the end table, which I'll probably forget to say later, and then the rest of this stuff I'll talk about as we go. So as we're done, you're going to be invited up to take a look at that. But first, before we get started, before I even introduce myself, I wanted to show a video that has nothing to do with meteorites, but it is one of the most fascinating videos I've seen that was introduced to me when I was doing a talk on meteorites. And even though it isn't directly about meteorites, it is every reason that meteorites interest me and I find fascinating about it. So, if you don't mind, this is my wife Sarah, by the way. She is the woman who's put up with this rock collection for a long time now. And
Unfortunately, the Laniakea Our Home Supercluster video would not load. The links to the Laniakea video and another video, The Great Attractor, along with descriptions, are listed at the end of this video and linked in the YouTube posting.
If you look at the star cluster that we exist in within our universe, what scientists did was go back and they mapped the flows in and out of the entire star cluster, which encompasses multiple galaxies. And it is, if you get to see it, just a fantastically beautiful video, and it does a great job of putting into perspective how small, how tiny we are, and how much of space we know absolutely nothing about, even as we send Mars rovers and other things out to look at. But since we can't get it, let's go back to the slideshow and just motor forward. That's okay, this gives more time for me to blab and more time later for you to. So I was going to give a big spiel about how it sort of blows the mind to see how small we are and how really insignificant we are. Which is still, no, go back, oh, sorry. Which is still
This
true.
is broken.
Hard to find good help these days.
I'm your daughter.
It's hard to find good software.
That's more true. I'm phenomenal help.
So, anyway, the questions that I will not answer for you tonight, but the questions that keep me interested in meteorites, and truly is what, I didn't do it, what truly drives me to keep doing what I'm doing is the big questions. Okay, so we all accept that we live in a universe. How do we know if we live in a universe? We can't get anywhere near seeing the edges of the universe. universe. Maybe we live in a multiverse. Maybe we live in something totally different. Does space ever end? If it does end, what's beyond? Is there other life out there? Probably, but we actually have no idea. We are very, very limited in our knowledge to not only our own solar system, specifically Earth, we don't even know if there's exoplanets around our solar system. So we know very little in the grand scheme of things. So that was my big spiel about the video, but that's okay. We'll skip over that. Just put your mind in a cosmic type of mind frame. So now we can go to the next slide, please. So a little bit about me. As Steve said, I'm a citizen scientist. I got into this entirely by accident. My job is a nurse practitioner here at the University of Minnesota in the neonatal intensive care unit. And we were actually at a medical conference, if you want to skip to the next one, in Jackson Hole, Wyoming, for my day job. And we went into a rock shop because I was shopping for fossils. And on the way out the door, there was an iron meteorite that they had on it. Well, I didn't know it was an iron meteorite. There was a big piece of iron in the doorway. And they had it on an iron mount. And on the back of the mount, they had iron flames welded on. So it looked interesting. And I asked the guy at the store, I said, what is this thing? He said, well, it's a meteorite. I was like, a meteorite? You mean like from space? Which, oddly, is the first question people ask. But of course, where else do meteorites come from? From space. So, of course, I inquired as to what the price was. Keep in mind, we're in Jackson Hole, Wyoming. It was $90,000. I didn't have nine. I had like $89.5 in my wallet. It was 12 kilos. This is a 27-kilo stone, so you can figure it was less than half the size of this. Obviously, I did not buy that rock, but it certainly piqued my curiosity, and it taught me that you could own meteorites. And so I went home, and my wife will attest to this, and I started doing research, and I figured out how to buy a meteorite. And in fact, you can go to the next slide. This is the very first meteorite that I ever purchased, the meteorite that started it all. It's called a Campo del Cielo. It comes from Argentina. One of the most common iron meteorites out there. And when I got this meteorite, I held it in my hands. And for those of you who have kids, and my wife's going to throw rocks at me when I say this, when you first hold a baby, it is a very profound thing. It is a life-changing experience. And this doesn't quite compare to that, but I will tell you that when I first got this rock, and she'll tell you it's true, it was profound. It was life-changing. You're holding something in your hands that's 4.5 billion years old. It is older than the planet we're walking on. Forget dinosaurs. This is way pre-dinosaurs. So that is what started my fascination. You can go to the next slide. And of course, like most collectors, I started with an iron meteorite. Why do most collectors start with iron meteorites before we get to this? Because iron meteorites look like what our mind tells us, what media tells us meteorites look like. They have all the big jagged edges and regoliths, which are the holes, and we'll get into more of that later. So most people start out buying iron meteorites. And I will say now that there's 3 different types. So there's stone, there's iron, and there's stony iron. Stones are the most common. Irons are make up about 7%, and then the stony irons make up the last 2%, and there's some overlap of other stuff that I'll explain in a minute. Go to the next slide, please. So irons, I already kind of told you why they look good. They look like they fell from space, and they aren't usually terribly expensive. Campo tends to be cheap. In fact, when I bought this, it was $400. And I'll tell you, that was the first time in my life I spent $400 on a rock. I put it on a credit card, and I was sweating it. It really, really got me. Anyway, iron meteorites look like they fell from space. This actually was a fresh fall, witnessed and recovered by 2 people in Norway. Big legal fight. It was found on private property, but there you have a right to walk on somebody's property, and if you find something that they didn't put there, you can keep it. So anyway, long court battle, but they got to keep it. Go to the next one, please. But iron meteorites, as cool as they are on the outside, it's really the inside that is exciting. So all iron meteorites, or almost all iron meteorites, have a fingerprint, a unique pattern that is unique to that iron meteorite. So iron meteorites are the core of a molten asteroid or planet. That planet or asteroid was destroyed back at the beginning of the solar system, 4.5 billion years ago. But before it got destroyed, that core cooled at what are called nuclear cooling rates. So 1 degree C every 10,000 years or slower. And that allows the iron-nickel compounds that are in the cores of meteorites, planets, probably like our own, to cool and go into its natural crystalline pattern, which is what you see there, called an octahedral pattern. The finer the pattern, the faster the cooling rate, generally. There are other factors involved, but in general, the finer the finer the pattern, which you see, these are all fine octahedrites. This is Muniolustra from Sweden. This is Kirgian. That's Muniolustra, and that is also. So that's a 4A iron, which is one of the finest octahedrites. Would have probably cooled very quickly, and has an absolutely beautiful etch that is sought after by jewelry makers. If you have, there's a lot of people that wear wedding rings that are made from meteorites. That would be where it comes from. Next slide. Compare that with Sokotelin. Sorry for the camera work if I'm walking too much. This is Sokotelin, 1947 witness fall in Russia. You can see that was the largest iron fall ever witnessed, by the way. Huge fall. You used to be able to buy pieces of this in the Montgomery Ward's catalog 30 years ago for almost nothing. Now you can't get it. It's very valuable. But you see the wide pattern, these huge crystals. In fact, if you cut a Sokotelin that's only this big, you may not see a pattern in it because it may just be one crystal. So this likely was from a larger paired body that cooled more slowly. This is from what's called Nantan, which is a Chinese meteorite. You see this is sort of in between the fine and the big, which we call medium octahedrite. That's a coarse octahedrite, the other one is a fine octahedrite. We go next. So that's irons. Irons are kind of everybody who collects, owns. The stony irons are the prom queen. They're the pretty ones. These are the girls that everybody wants. And so stony irons are a little bit mysterious in that we don't fully understand how they formed. We, until recently, believe that they formed along the core mantle boundary of a differentiated planet or asteroid. So differentiated just means it's large enough that it has a molten core, the heavier elements sink to the center, the silicates float to the top. What they thought was that the mesositerites, which is one of two types, and the pallasites, which I'll show you in a minute, formed along that core mantle boundary where you had some mixing of the silicates and the irons. You can go to the next slide. Now we believe that probably it was actually an impact of a large iron meteorite and a stone meteorite that melted together. When meteors impact, when asteroids hit, it is a massive energy-releasing event. And I have some impact melts up here that are called impact melts because you can actually see the flowing metal veins and the flowing rock veins where this flash melted because of the force of the impact at the time. So the theory is probably these weren't from the core mantle boundary, which should theoretically be very thin and maybe just smashed together. I think it could be both, or either, or maybe neither. Because if you look at, hang on one second. If you look at this, it's a fairly evenly dispersed metal pattern. All the white stuff is metal. These are silicates. And this is fairly evenly dispersed. If you go to the next slide, this is, again, Esterville from Iowa. So this was a witness fall in Iowa in 1871. Also mesosiderite, but this, you see, is distributed totally differently. You have blobs of iron, big spaces. This looks more, and if you look at it under a microscope, looks more like an impact melt. There's vesicles, there's bubbles where expanding gases opened it up, which is very rare in meteorites. So I am led to believe that this probably was the result of an impact, and that some of the others are from a core mantle boundary, or maybe something else. Next slide. But pallasites, the other kind of meteorite, the other kind of stony iron, these are everybody's favorites. Katie, can you turn that up for a minute? So pallasites have, they're space gems, and the gems, pull it back a little further, and the gems that you see are actually, we call them olivine in meteorites, it's peridot, the August birthstone. So if you have a ring or a necklace with peridot, you have the same stuff that you find in asteroids, except from Earth. And there are jewelry makers who love to make jewelry out of this. In fact, she's got earrings and I don't remember what else, but she's got something. Every now and again, you have to make up for the mess you're leaving all over the house with the rocks. Next slide, please. So pallasites are beautiful. They don't have a lot of function other than being beautiful. This is one of the largest slices of imlac, or it is the largest slice of imlac ever cut. Next slide. You can see me. Oh, I didn't put the one of me kissing it and trying to lick it in front of the owner, but anyway, it's about this big. It's absolutely fantastic. It came from the British Museum, and it's one for the ages. All right, that's the stony irons. Next, we're going to get into sort of the ugly ducklings, but the scientifically most interesting, by far, scientifically most interesting group, and that's the stones, specifically chondrites. So I have to give you a little bit of background, and you can go to the next slide. So chondrites are rocks that have chondrules. Go back one, sorry. Chondrules are these little round balls that you see, and when you come up, I have several rocks up here that are chondrites and have large chondrules. this one here, we have a carbonate, this one here, we have a carbonaceous chondrite here. So come up and take a look. Chondrites, now you can go to the next slide, were formed 4.67 billion years ago. They are direct leftovers of the nebula that created our solar system. Chondrules are the dust that you see in the clouds. You can go to the next slide. That through time, they accreted. They stuck to each other. This is a very hot, soggy ball of stuff. And as these dust particles, these little globs of, I'll tell you what they are in a minute, stuff, stuck together, they started to accrete into rocks. Those rocks hit other rocks. You can go to the next slide. Next slide. And eventually, rocks hit bigger rocks, hit bigger rocks, hit bigger rocks. Pretty quick, you have planetesimals, planetoids, and then all of a sudden you have a sun that's sort of, everything is revolving around the center of gravity. You can go to the next slide. Actually, you can just go to the next slide. And all of a sudden, one day you have a solar system. Obviously, this is our solar system. You have the rocky planets that can tolerate heat closest to the sun. You have the gas giants farther away where they can not have to evaporate and be burned up by the sun. I don't care about those. What I care about is this right here. That's the asteroid belt. 98% of the meteorites we have come from the asteroid belt. Now, back to chondrites. So, go to the next slide. 1969 was a big year. It was the middle of the Apollo missions, which, by the way, I have some Apollo lunar up here. You can, well, I'll explain that in a minute.
Yeah,
Yeah, you're going right.
No, you're
1969, our laboratories were all geared up for the lunar missions, so we were ready to study space rocks. We were studying space rocks. And in 1969, in Murchison, Australia, and almost simultaneously in Chihuahua, Mexico, in a town called Allende, fell the Murchison and Allende meteorites. You might notice that the names match where they fell. That's because that's how we name meteorites. We try to get it off the location most near where they were found. If there's multiple names, sometimes they get numbers, sometimes they're named for the next zip code over or the next river or whatever it ends up happening. Murchison and Allende, you can skip to the next slide, are special chondrites. They are carbonaceous chondrites. That's the most primitive. And the reason I wanted to go back to the slide and sort of give you the background is because everything you see here is unaltered by the last 4.5 billion years. So all of these little circles and all of these white CAIs, which I'll explain in a minute, are unaltered time capsules from the last solar, from the solar nebula that created our solar system. So when scientists started looking at these two super fresh falls, which is great because they didn't get degraded by terrestrial processes, they were amazed at what we found. We found amino acids. Just in the Murchison meteorite, we found 131 amino acids. We're still finding more, including all 21 that we find in the human body. We find salt. I think I already mentioned, a piece of salt you can come up and take a look at. All in the Murchison meteorite. They found salts, they found sugars, they found water, and they found sulfides, which, by the way, when you open a fresh carbonaceous chondrite, you'll smell the sulfides. And when you cut a carbonaceous chondrite, your wife gets really angry because your house does not smell very inviting to anybody who walks in. It smells like a pile of poop. All right. So chondrites have been a wealth. No, you can go ahead to the next slide. Have been an absolute wealth of knowledge. Keep going. So other stone meteorites that we have, the two most common are the Moon and Mars. If you come up, I have a whole bunch of lunar meteorites here, a couple Martian meteorites there. Most of the lunars, I'm going to say don't touch if they're in a stand. If they're laying down, you're welcome to come up and hold them and look at them. Asteroids hit the moon, eject a piece of rock, flies through space. Most of it gets sucked into the sun. Every now and again, one of these pieces intersects with the Earth's orbit, manages to survive the crash through our atmosphere, which is incredibly dense and hard for things to get through. Only about 10 meteorites a year actually make it through the atmosphere and survive to hit the ground. And then they get picked up, almost all of them, in Northwest Africa, which I'll get to in just a minute. Next slide. Actually, this is just a picture of a lunar meteorite, very similar to what the Apollo astronauts brought back. Next slide. The other place we get meteorites from, and I sort of mentioned this already, was Mars. I have a couple Mars rocks up here. Mars is a little less common, but we're getting really good at finding Martian rocks. And so suddenly, what used to be in the neighborhood of $50,000 a gram, you can now buy for $50 a gram. So it's become much easier to own both lunar and Martian meteorites for people. Next slide. All right. here's where we get into the cool stuff. So this is what's called an achondrite. So it does not have chondrules, which means it came from a differentiated body, which means it had some kind of molten processes where it separated into a core and a mantle and a crust. And this particular stone, my partner and I brought to market 3 years ago. Nobody believed it was a meteorite, and lo and behold, it's a 4.6 billion year old piece of lava. The oldest known lava in the solar system. They're still doing research to try, based on oxygen isotopes, to determine what area of the solar system it may have come from. Don't have that information yet, but it's absolutely stunning and beautiful. So achondrites, again, all of them, almost except for the Moon and Mars, come from the asteroid belt, but we're still finding stuff that is new and interesting. Next slide. Here's where it gets cool. This is why I do meteorites. It's not the stuff from our solar system that I care about. It's interesting, it's fun. A piece of purple salt from outer space is cool. But in 2017, we had this 10-mile-long cigar-shaped thing come through our solar system. We didn't have any idea it was here until it was on the way out. Came in, went around the sun, and was actually 20% out of our solar system already, and an astronomer said, hey, we got this thing, and we mapped it, and it doesn't look like it came from our solar system. Lo and behold, after a whole bunch of analysis, it is indeed an interstellar object. This didn't come from what made our solar system. This came from another star system, with no idea where. In 2014, we just found out this last year, there was an interstellar meteorite that impacted the Earth over near Indonesia, landed in the ocean, and it was classified because they weren't sure what it was. It came from outside of our solar system. They were able to track that. And the government didn't want to give away the secrets, didn't want to take chances. So last year, they declassified the information, and now there's several scientists who are trying to go out, and we know roughly where it fell, and they're going to try to go down and find this meteorite and see, what it looks like. Of course, it's been in the ocean for 10 years, so how much scientific value, if they're able to find it, is questionable. But it happens, and these are the things that I hope someday we are able to find and confirm and see what else is out there. When you talk about the big universe, this is what's going to give us the clues. I'm going to backtrack again for a minute because I just forgot something. When I was talking earlier about chondrites, carbonaceous chondrites, here's a carbonaceous chondrite. I'm going to just show you because you're going to come up and look at this later, and you'll see the white circles. Those are called calcium aluminum inclusions. Calcium aluminum inclusions are the oldest matter in the solar system. They were solids before anything else was solids, and in fact, some of them are pre-solar. So they date from 4.6 to about 7 billion years old. It is one of the oldest things you will ever be. It is almost the oldest thing you'll ever be able to hold in your hand. But in addition to CAIs, in the carbonaceous chondrites, which have virtually no iron, they have microdiamonds. This is the coolest thing. They're 12 billion years old. Microdiamonds, 12 billion years. 12 billion years ago was a billion years after the Big Bang. We don't even think there was light in the universe when this happened. So microdiamonds may very well be direct descendants of whatever started our universe. It's fascinating stuff. There's other diamonds, carbon nanodiamonds, which we use industrially all the time, but they're not anywhere near that old. They're anywhere from the age of our solar system down to about 7 or 8 billion years old, but not that old. So anyway, those things excite me, obviously. So next slide, please. By show of hands, has anybody seen meteorites falling? Has anybody seen a falling star? Has anybody seen a really big falling star? All right. So most of the you have, was it here locally?
No, Madison, Wisconsin.
2010?
No,
Oh. When?
1952.
Oh, that's. I don't know about that. So most of the time that we see falling stars, they're pea-sized ice chunks from comet tails that are leftovers. A little bit of ice, a little bit of dust. And they come and hit the atmosphere between 30 and 50,000 miles an hour. Meteorites generally hit the atmosphere going between 20 and 150,000, with an average being 30 to 50,000 miles an hour when they first hit. You can go to the next slide, please. And so these little pea-sized things just make little streaks.
I mean, we can try it again.
Let's try it again. But when you see a big meteor fall, and I'm hoping, this one I really hope the video works because this will make you believe.
Yeah, there it is.
I don't know if we have volume.
I think it's when it's embedded.
Oh, we don't know. Okay. So Russia, 2013, just had the 10-year anniversary. This was the first meteorite that I was aware of fell from space, and this was pre-collecting days for me, but it was still cool. So 2013, this massive asteroid comes through, it's about the size of a school bus. We had no idea this thing was coming. Nobody in Russia knew it was coming, so people are driving along on their dash cams and they see this massive, low-angled, what appears to be slow-moving, even though it's like 27,000 miles an hour, huge bright fireball, and then it goes dark. So it was a dead quiet day. People in Russia, in Chelyabinsk, will tell you it was a dead quiet day. There wasn't a breeze. The wind speed was 0. This has all been studied. And people said after this meteorite went through, everybody parked their cars, buses pulled over. It was eerie silence, is how they described it. And then 3 minutes later, all of a sudden, I don't know if we can rewind the video or not. If we can't, that's okay. Everybody who's standing at their windows, totally unsuspecting, finds out that there's a shockwave coming. Well, they don't find out that it's coming. It comes. And the sonic boom and the blast wave hits. And it blew out windows in 7,500 buildings. And it sent 1,500 people to the hospital. It didn't send them to the hospital because they were hit by anything other than flying glass. So it took 3 whole minutes because it detonated at about 23 miles above the Earth. And that shockwave took 3 minutes, speed of sound, to get to the people in Chelyabinsk. So everybody's standing around talking about this amazing, they thought they were under attack, there were all kinds of crazy theories. And all of a sudden, boom, everything explodes. So that is what a big meteor looks like when it comes through the atmosphere. I will tell you very well, we can go to the next one, and I'll talk about this one as it's going. So this is peak scale 1992. Hopefully the video will work. Oh, we are spinning. 1992, Friday night, October 8th, Friday night, 10 to 8. You're killing me.
Sorry. It started.
Anyway, this was, at the time, the most videotaped fireball in history. Because what happens on a Friday night in October at 8 p.m.? Football! And if the video will work, you'll see the football stadium lights as they're panning the camera. So 16 different people videotaped this in 7 different states. It fell from West Virginia, and then it was witnessed all the way up through Pennsylvania and finally into New York. I don't know where we're going now, but back in time, I guess.
I'm
There
trying.
you go. There you go. Got it.
Oh my God.
As a hunter, see, there's your lights. That fragmentation is exciting. That means there's rocks on the ground. Because what happens when these meteors come through, yeah, they hit the atmosphere going 30,000 miles an hour. But after a very short couple of seconds, they slow down. When they go into dark flight, they're at terminal velocity. 200 miles an hour, 250. So like a well-hit golf ball is all the faster they're going. And that's high up. So you're talking about 20, 30,000 feet, the temperature's minus 100. So do you think meteorites are hot or cold when they hit the planet? No. That is the very first, yes, cold. That is the very first thing that I hear from people who think they find meteorites. It started a fire in my field and the trees were burning, and you just hang up because that isn't what happened. So most people don't know because of the movies, but meteorites tend to be cold. They've been in minus 100 degrees for several minutes. And they came from minus 200 degrees in space, heated up for just a couple seconds, so the outside of plates melts off, and you can come up and see the crust on some of these. It's just a thin black line. Try to find a good one. I'll find you a good one. You can come up here. The rest of the stone is untouched. It doesn't even get warm. And so when it's flying, if it survives through the hot flight, it gets through the ablation phase, then it gets very cold and falls to Earth at roughly room temperature. In this case, they only found one rock. Next. And that was the rock that, I know, shocked, nobody saw this coming, that fell through the trunk of this car. So this is a great story. How are we doing on time? All right, I'll pick it up. 17-year-old girl owned this car, had owned it for a week. She paid $600 for that Chevy Bel. She was sitting in her house that Friday night in her apartment, and all of a sudden she heard what she said was just a god-awful crash. Had no idea what it was, didn't think anything of it. The next morning she went out to get in her car. The car wouldn't start. And she walked around. There was no gas because there was a big hole in the tank. And underneath it was a rock. The only rock recovered from the peak scale meteorite. And in fact, I have a piece of that rock, one of only 6 slices made from the chunk that broke off right here, made public. So I have a slice of that, and I have a photo, or an actual photo from the car and the owner, actually the girl's dad, standing by the car in the meteorite article. So you're welcome to come up and take a look at that.
Should we come up from the rock to pay for the car?
So here's the thing. Yes, that is the fun part of the story. So she paid $600 for the car initially. How much do you think she sold it for 3 days later? Anybody want to guess? This is 1992, so
For the car or for the meteorite?
for the car. They sold the meteorite too, but the car, they got $250,000. She got $250,000. It sold a year and a half later for $1.5 million, and it sold. I think the last time it sold for $6.5 million. Now it travels the world. They've largely, what I'll say, kind of departed the car. You could buy hubcaps, you could buy lug nuts. They're parting it out to people who want to buy parts of it. But rocks that hit man-made objects are incredibly valuable. So, those are some ancient falls, but we've had a really active year this year. If you can go to the next slide. This is cool.
So how much is the rock worth in comparison to the car right there?
Now most of the, it was a 6-pound rock. Usually we say kilograms, but so what's that, 3 kilo? Actually, I think it was a 6 kilo rock. I'd have to look. 6 something. Now it sells for about $250 a gram. So you can extrapolate out, if you can get it, but you can't get it. That's the problem. You just can't get it.
People cut them up.
Well, most of it is in the Chicago Field Museum whole. Some of us who own cutting equipment maybe have cut some. Yeah. So some of it got cut up initially and sold to pay for the stone. Meteorite bought the stone from Marlon Sills, who was a cutter who lives in Montana, who bought the stone initially. That's kind of how meteorites work. This just happened. Valentine's Day, France, this year. This was only the 3rd asteroid ever to be tracked coming into the atmosphere. And it was only tracked for 2 days. We have a very hard time seeing asteroids, which is why it's important that we get better at it. We only see about 1%. But a very astute astronomer saw this 2 days before it came in. They calculated the trajectory, and lo and behold, there were photographers set up with the coordinates they were told to at the time they had. They opened their shutters, and lo and behold, the rock dropped exactly where it was predicted to drop, and they got pictures like this, which is stunning. Next, please. So this guy, I don't know if any of you have seen the show Meteorite Man. You can go forward and then we'll come back. I put those on order, sorry.
You're not that far gone yet.
What's that?
You're not that far gone
Right.
yet.
Steve Arnold, who's a friend of mine, interesting fellow. They're both interesting fellows. Super nice guys. He flew over to France. When there's a known fall, people come running to find it. So he flew over to France with a whole bunch of other people to find this fall. So we have radar now that was developed by a scientist at NASA. So once they get within the atmosphere, he has a system of radars that will track the fall, and you can tell at different altitudes how much material is left. So if it doesn't survive, you're not going to see anything below 20,000 feet. It just disappears. If it does survive, it looks like a hailstorm, and the bigger it is, the bigger the hailstorm. So you get swipes every couple seconds, and you can track these meteorites as they fall. So it has become much easier. It's still really hard, but it's much easier to find meteorites. Freshly fallen meteorites are valuable. I didn't bring this one tonight for that reason, but I actually have the main mass, go to the next slide, that Steve Arnold found in France just a couple weeks ago. He sold it. He sent it to me. He was going to cut it, and then a museum in France bought it. It's 175 grams. So 30 grams to the ounce, 300 grams, so half, it's what, 5 ounces, not even. Any idea, anybody want to guess what he sold this stone for? I don't even like having it in my house. $175,000. $175,000 for what we call an ordinary chondrite. It is not a special stone, except we track. Oh, that's not cool. That's not the right stone. Anyway, no, don't go forward. It's fine. We're moving on. So anyway, the value is high, and for that reason, people chase new falls. That is one of the best ways to find a meteorite, is to chase a new fall. So there's a couple hundred people around the world. There's a fall. They all get their go bags. They jump on a plane. I've become one of these, although not quite as prolifically as some others. And you chase them. This is Muskogee, Oklahoma, this spring in January. Fresh fall. Go to the next slide. This one is from Mississippi. I did hunt that fall. Go to the next slide. This is from Georgia. And the next slide, again, these are all people that chase these. To give you an idea of how valuable anything that touches a meteorite is, I want you to really look at this picture. And the next picture. Because the meteorite impacted the road, and it left a divot. Not a big divot, just a divot. The guy actually got his saw out, and he cut out the piece of the road. We said, is that legal? He said, well, it's got my name. The road was named after him. He owned property along it. So he said, I think it's okay. So then he did fill in the hole. But, I mean, it's backwoods Georgia, you know. But that is how serious people are about the value of meteorite. And so this, by the way, I don't know what the selling price was, but that's already sold. I mean, that as soon as you get those out and you put them on the market, they're gone. Very wealthy collectors snapped at them. Excellent. This is another one from Muskogee. This was found 2 weeks after the fall. A guy started raining, and he couldn't understand why rain was coming in his garage, so he walked outside, or he went up on the roof, and he found the meteorite still sitting next to where it didn't quite break through. Again, they don't fall super fast. Next slide. So what did he do? What happened? Oh, there we go. So what did he do? He went up and he cut out the roof. And now the roof, a friend of mine named Roberto Vargas went and he bought the roof parts from him, and he bought the mast that he found on top of the roof. And it was only $35,000, but still it was 35, I mean, it just landed on literally landed on the guy's roof. So there's a lot of money in this. The other way is, you can go to the next slide, the other way that we find meteorites is called a find. A fall is a witness fall. It's documented. There's people all over that go online and mark where they saw it and times and all that jazz, and then it's confirmed with radar. Finds are 98% of the meteorites we find are meteorites that have fallen over time, and people go out and find. Almost 100% of those come from the deserts. Anybody want to guess why we find all of our meteorites in deserts?
I think roads are the same.
No vegetation.
All of the above. You're all of the above.
It stands out.
Well, all of
chunk of things in the middle of a sand pile like that.
Also true. So, in Minnesota, how many meteorites do you think we found? Total, ever? 9. I have 7 of them over there. It's the largest collection, largest intact collection on the planet. So you can go take a look at those. But only 9. Why do we only have 9 meteorites in Minnesota? Do fewer fall here than fall in Morocco or wherever? No, it's roughly the same. We've averaged out over the years. And in fact, Antarctica is like the most rich meteorite place you can go. You step out of the helicopter and there's hundreds of them. Because it's a white desert. You can see the black rocks sitting right on top, and they never really get weathered away. It's the same in the desert. So these people go out. Now, nomads, since the 1980s, have learned that there's a lot of money to be made. This is a billions of dollars a year industry. So people have gotten really good at finding these rocks. Most of these rocks that I have up here came from the desert. This actually came from Australia. This came from Argentina, the desert. But desert, Russia, not desert. Oh man, desert. desert, not desert. Anyway, most of them come from the desert because they can sit there for millions of years at a time. In Minnesota, we get snow, we get rain, they're porous. I already said they've just kind of loosely stuck together. They get wet, they freeze. What happens to the roads when they get wet? They freeze, they thaw, they get wet. You're all geology nuts. You know what happens to the roads when that happens. So the same thing happens in Minnesota. And plus we have lakes and forests and all the other things. So they're just harder to find. So anyway, most of our meteorites come from the desert. You can go ahead and keep on piecing through. Next. So what's next? I'm almost done. Thanks for bearing with me. This is Ryugu. This is one of the asteroids that we've actually sent a mission to, collected, I think sub 1 gram, but collected samples from, brought back, and is now being analyzed. And this is a carbonaceous, turns out a carbonaceous asteroid. So this is super pristine, will have lots of amino acids, lots of sugars, water, salt. So it will be very fascinating to analyze, get the analysis back from this, totally unaltered from any terrestrial processes or falling through the Earth. And here's actually just a picture of Ryugu when the liner was on it, so you can see it just looks like gravel.
How big was the asteroid?
I don't remember the size. It's pretty, I mean, it's a large asteroid, but I don't remember. You can Google Ryugu, R-Y-U-G-U, and you find everything. I don't remember how big. Next. And so now there were 2 companies. I think one merged with another company, so now there's one company that are actively trying to get to mine asteroids. The challenge with mining asteroids, so the estimated value of, it wasn't Psyche, smaller than Psyche, but it's so many zeros, I don't have any idea what the actual number would be in value because they're so rich in iron and nickel, gold, silver, micro elements, but it's a massive, huge. And so what they're trying to do is figure out how they can get up there, actually mine it from the asteroid, process it in space, and then fly back the precious metals. Because you can't drag the whole asteroid back, and if you're going to be bringing iron back, then wait till you come and lift these up. It's about 413 pounds a cubic foot. I mean, you're going to have a massive problem if you start trying to drag it. So we'll see if that happens. They say it will be within our lifetimes, meaning the next 30 to 40 years. I don't know. We'll see. Scott Peterson, another brand new scientific way of looking at meteorites, is my buddy Scott, who just left a little while ago, who I more or less mentioned earlier, but he's doing micrometeorites. He found all of these in Minnesota. He goes on rooftops, and he's developed a process. He's one of only 2 people in the world. Developed a process to find and identify micrometeorites locally, and he finds thousands of them. And what we're finding, based on the early studies, is that these are all interstellar. These are from a supernova other than our own. So now they're dust suction, truly dust suction. So they're microscopic. I have one up here. We can throw it on a microscope if anybody wants to see it. But they're very, very small. So it'll be interesting to see how much scientific data we can get out of them. But some of them do have bubbles. So whether it's water or air, I don't know yet. It's a brand new science. So a brand new discipline. So we'll see what ends up happening. Last, before I invite you all to come up and get a treat and go to the bathroom and then ask questions, everybody wants to know about Ann Hodges. So I said anything that gets hit by a meteorite is instantly valuable. People take off roofs and cars, it roads, doesn't matter. Ann Hodges is the only person to ever be struck, the only confirmed person to ever be struck by a meteorite. There have been a whole host of reports, and they've all been debunked. This poor lady was laying on her couch at 10:30 in the morning in Sylacauga, Alabama, taking a nap. And all of a sudden, she got awakened by what she described as a loud boom, and her ceiling, to her, it looked like it collapsed. Rock came through the roof, through the ceiling, bounced off the wall. I think it hit a shelf, and then it slammed into her head. So she survived, obviously, and got a fancy bruise for it. The problem with Ann Hodges, she wanted to keep the meteorite. I'd want to keep the meteorite too. She was a renter. So this actually established modern property. It went through a long court process, and it was determined that the owner of the property owns whatever falls on the property. And so after 3 years, she held on to this rock. It was taken from her, but at that point, in the 1950s, 1953 is when it fell, so by 1957, people had lost interest. We didn't have internet and all of that. I mean, people just forgot about it. So the value of the stone went way, way down. They ended up, the property owner ended up donating it to the Sylacauga Museum, which is where it sits today. I have a piece of that meteorite, the actual hammerstone, right here. There were only 12, so they studied this meteorite with a core sample. So they went in with a core drill, and they pulled out a little core about this big, and they only made 12 slices. Those are the only pieces available to the public from this meteorite fall. Most of 10 of the discs are still intact. 2 were broken up, and I have a piece of wood. So you can come take a look at this if you like. That's the Ann Hodges story. All right, that is all I have for you. So thank you for staying awake and coming to see me on a
Bring the lights up and come on down and who brought the cookies? If we've got some questions, we'll go ahead and ask. My first question is, I need to get Scott's phone number and see if we can get
Yes,
up on the roof of 3M.
Oh,
And
That's
I bet I can get a dozen people from 3M Tech Forum to go there with them.
I'll give you I'll give you, yeah, we'll exchange it. He would love to. And he also does speaking engagements. It's really good stuff.
Okay.
And now micrometeorites, it's all pictures on our microscope.
That's fine.
But it's fascinating stuff.
I'm looking for speakers for next year. So that's,
Scott is a good one.
all right. Questions?
Yeah, with satellites and everything, do you see more meteors and how they come down?
We are still, so the problem with meteors, when they're in space, they're relatively non-reflective. They're not dense, and they don't really have anything in them to reflect light, especially the stone meteorites, which are generally dark. So it's very difficult to see them. There just isn't a good way to see them. If you catch them when they fly by the sun, and they catch them more than one day in a row, and they can determine that there's a course, they can find them. But we know of less than 1% of all the asteroids that are out there. So that is one of the biggest issues right now is, space defense, trying to figure out where they are and when we find them, how to deflect them.
But what did you see? What did you have on that picture right there from the satellite?
But after it, well, no. So this is not. No, you'd have to be at way too low of an altitude. I mean, this is already in the. This would be already well within the atmosphere. Sometime, I think there's been 2 photos caught from satellites before it goes through the clouds. Looking down, you can see the bright flash, but it's the same thing you see from below.
Yeah,
You're just,
yeah.
So by then, it's too late for. You can maybe see it, but it's not something you can predict. We've only predicted 3.
You might want to repeat the story you told me about Crater Lake in Arizona.
Canyon
I found that
Ditch.
fascinating.
So this, by the way, is part of the Canyon Diablo meteor. I have another up here somewhere, I thought. But so Canyon Diablo, a meteor crater in Winslow, Arizona. I don't know if anybody of you have been there. It's one of the largest craters on the planet. It's almost a mile wide. It's about 49,000 years old. And when it was first discovered, everybody assumed there would be a massive rock in the middle of this thing. So they went and looked. There was nothing on the surface. They actually sent in a core drill, and there was nothing. Zero anything from outer space. So what we've learned over time now and watched as other meteors have come in and done a whole lot of new math is that this meteor exploded about 8 miles above the planet. So it comes in at such a velocity, it was an iron meteorite, and it condensed the air so significantly in front of itself that it was the condensed air that blew the crater out of the ground, and then the meteor actually exploded into a bunch of small pieces 8 miles up. And we don't find any meteorites within a 4-mile radius of the crater. But if you look at a map, it's a perfect circle around the circle 4 miles out that people start finding the iron because it blew up high and fell out. So that's the
How
story.
much of that is still left to be found?
So technically, it's all in protected areas now. I think all of the areas that are public are funded out. There are people who still go in and illegally go at night and try to find these rocks, but it's getting tough. All of the what I would call staple irons, Campo del Cielo, probably the second biggest. We used to think it was the biggest iron that's ever fallen. Now we know Alatai, which is the where did Alatai go? Anyway, Chinese meteorite. I have it here. Oh, here. Alatai is actually the biggest. They actually just found a single stone of this that weighs 123 tons. So Alatai, and that's just one. There's many. So Alatai is probably the biggest iron to ever hit. That's in China. But anyway, iron meteorites generally are becoming hunted out, the ones that we knew about. So unless we find something new, the value is going up, 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 which is really good for guys like
How much damage would that have done? If that had happened today,
That's a great question. Not a ton, probably outside of the immediate vicinity. It wasn't enough to cause a nuclear winter to throw ash and dust into the atmosphere. So it would have been just localized. Yeah, I mean it would have been everybody in a 10-state area would have. Yeah, oh yeah.
that would have gone. But
The funny part is the house would have been gone with the asteroid still 8 miles up. You would have been, the house would have been vaporized. I'll just kind of go this way. Yes, sir.
Where do the micrometeorites come from, and where do you find them?
Micrometeorites. So we think this is a totally new discipline, and Scott's the guy, and I think we're going to hopefully get him here to talk to you next year. Micrometeorites, we believe at this point, are from supernova. They were created during a supernova. Some ours, and some we believe are actually older than ours, so they would have come from the supernova in a neighboring star system. Very, very early on in the science, and difficult to study because they're so incredibly small. I mean, it's little with us. But more coming on that. That's what we think so far. I skipped over you, sorry. Somebody over here had a question.
A number of years ago, a meteorite fell down near La Crosse, and we actually went down there for a couple of days and didn't find anything.
Was there a whole circus of people down
There was.
there? And news people?
Yeah.
The meteorite hunt. Yeah, that was, for the love of Pete, I have a piece that I didn't bring with me. Mifflin, Wisconsin. They only found a total of about 3 kilos, so it was a small fall. Most domestic falls are. We don't find a lot of really big ones, but about 3 kilos. Very little of it was made available to the public. I have a real thin slice, but that's very valuable today. It's upwards of $150 a gram if you can find it, and it's really tough. Yes, sir?
I didn't hear you mention, maybe I missed it, meteorite that we filled with dinosaurs. Do you have a piece of that?
No. I wish.
Sorry, your wife.
No. Yeah. So actually, Chicxulub would have punched all the way through right to the core. There probably isn't any bit of that left. Even if it didn't punch right through the core, which, by the way, we think is probably why we have the huge iron deposits up in northern Minnesota. They think there's a massive crater that they suspect way back billions of years ago. A meteor was large enough that it actually punched all the way through and essentially the iron splashed up through the holes and the cracks that this massive impact would have created. This is long before people looked for that. It's just a long time ago. But anyway, Chicxulub. So Chicxulub, we don't have anything from, but it was such a massive event, and there was so much dust and ash. I mean, it caused a nuclear winter, years and years and years. Probably would have buried itself anyway. There was so much debris. So what we see is the KT boundary if you look at Earth samples, but we don't have anything other than what we believe to be the crater outline to even verify. Yes, sir?
Isn't the energy of that process such that everything that hits is vaporized?
Likely in that case, yes.
Yeah.
I mean, it would have vaporized. If it had fallen over water, it would have vaporized the ocean and just hit the shore. I mean, it's something that size. It's massive. The heat is incredible.
So did you say you found organic materials in some of these?
Yes, lots
So
of.
how do you get the organic materials without life?
This is why I love meteorites. That's exactly the question that nobody can answer. And I think it's proof of life outside of our solar system. We actually just recently, I don't even think this is published yet, but you're going to hear about it soon. They have actually found a strand, basically, of intact organic protein. Had to have come from life. They were working to double and triple check that it couldn't possibly be terrestrial, but it came from the inside of a carbonaceous chondrite, and I suspect you're going to hear a lot about that in the next probably 2 years. So there are, like I said, 131 amino acids. I don't have Murchison here. Did I bring it in it? I don't have it in here. But this is a carbonaceous chondrite here, and any one of these has loads and loads and loads of amino acids, salts, sugars.
Why did you emphasize that has to come from life?
I'm not saying it has to, but you have all of the building blocks of life. How did you get there? I started this talk by saying, where did any of it come from? You can't get something from nothing, we think, but something somewhere at some time had to create something. How? I have no idea. These are questions that I will never be able to answer, but it's what I love about these. I don't know the answer.
With numbers like people are selling these for, is there an organization that authenticates, double checks, triple checks the numbers?
So, yes and no. First of all, I tell people, it's more or less jokingly, but it is the best regulated, unregulated market in the world. I would say it's better regulated than the stock market in most cases. It's a very... What's it? No, right? Probably true. So there's a couple bodies. International Meteorite Collectors Association is the most famous. I actually sit on the board of that. We have about 450 members right now worldwide, and basically what we do is check your references, make sure that you have had upstanding deals, there's never been anything shady, and then you get a number. And what we basically say that, we will say that this person should be a reputable dealer, and if there's a problem, they won't resolve it, or if you find that something's not real and they won't resolve it, we'll step in on your behalf. Otherwise, outside of actually sending it to a lab, which I do all my own, I don't do my own classifications, I send in my rocks for their own classifications, there really isn't a way to say 100%. I mean, many of the meteorites, like if I brought you, I was talking earlier about impact melts. This is an impact melt, and if you come back up, you'll see the iron blobs and the light colored melt. This is called test set at 004, and I actually, the 400 kilo stone that I have en route to my house is this particular meteorite. When you cut it, it's very easily identified. It's very unique. And there are many meteorites that are very unique and easily identified, and you say, yep, there's no question about it. Campo del Cielo, if I cut a Campo, I'm going to just look at it and say, that's Campo. And with 99.999% certainty. But if you actually want to say with absolute certainty, you have to go. Yes, ma'am.
Remind me, which type of meteorite was the Tunguska one back in the early 1900s?
If only we knew the answer to that question. We think it was a, we think it was a comet. So, Tunguska, if you're not familiar with it, 1908, northern Russia, was by far the biggest almost impact that humans have ever witnessed. There was this massive bolide that came through the sky, and people who lived in the area, and there weren't many, I think there were a total of like 70 some odd accounts, said that the heat from the flash, they thought they were going to die. I mean, it was this massive rush of heat. It flattened 800 square miles of wilderness. flattened. There wasn't a tree left standing anywhere. There's no crater. There were never any meteorites found. So we think that it had to be large enough to cause that much damage and have that much of an impact on the ground. And if we're not to leave any trace, well, comets are mostly ice and dust, right? So probably it was an arid comet that almost impacted the Earth and detonated high enough and then just melted. So there isn't anything left to find. That's the working theory.
Didn't they see the shockwave patterns on whether
4 days.
It was going around the circling the
4
world?
days. It circled around the world. People described it as ghosts of lights all around the world because this was such a massive impact and such a massive event that for 4 days and 4 nights the sky glowed and danced like northern lights all day around.
And the barometers around the world were showing the spike, if I remember correctly.
Well, you're older than I am, if you remember that. I don't know what I haven't heard the barometers, but yes, there are there are thousands of witness accounts of the skylights from the Tunguska impact.
The micrometeorites,
Yes.
What type of rocks are they?
They are barred olivine mostly. Olivine is peridot, and they also have iron nickel. Can we go back? Is it too late to scoot back to the pictures of the micrometeorites real quick?
Really beautiful on the screen.
They are beautiful. Keep in mind, these are highly magnified. These are actually layered photographs, so these are multiple photo images stacked on top of each other. But the tips here, these are iron nickel, and then this is barred olivine, and then inside, I don't know if I have a picture. Some actually have air bubbles, water bubble, or possibly water. I don't know. I shouldn't say that. Bubbles of stuff. But we're still trying to figure out how to get into that micro side. These are small. I mean, this is dust, dude. These are very, very tiny. You can come up and look. I have one on a slide up here and hold it up. And I mean, they're very, very small.
Where on the planet might one go to find such things?
Anywhere. They're all over. So it's estimated that 1 falls per year per square meter of land space. These are actually a big problem for the space station and other stuff because although most of them are dust sized and don't do damage, if they're just a little bit bigger, they can plug a hole through space station and solar panels and all the other stuff floating around in space. So he finds them all locally. What's that?
So in relative terms, they're common.
Very common. I went with him. We went to Woodbury High School two years ago. Maybe 2 years ago. We went on the roof. It was a crappy day. It rained. There were puddles all over the place. So you don't want to go after rain because it's probably going to wash everything out unless you can get around the bases where the gutters run. But anyway, we went on the roof and kind of went through the puddles and whatnot. And I found 3 my first time out. He found, I think, 12 on the roof after a rainy day. So they're very common. If you can find a flat roof that is not blacktop, tar, or shingled, because shingles are full of iron stuff. You go over them with a magnet and you get all kinds of stuff that sort of clouds your field. So he can actually go through and pick these out. I am not that skilled, but he's very good at it.
So you like using a magnet?
So yeah, we a fishing magnet with a plastic bag. So you take the fishing magnet and you just gently go and sort of touch, but not quite touch all around in the corners where things have built up. And then he goes back and he has buckets of this stuff, and he just literally pulls them on a slide under the microscope until he sees a micrometeorite, plucks it out, and then he spends hours and hours and hours.
A friend of mine who was from Ontario said that there's this huge nickel deposit south of Sarnia.
Yes.
And from what I've read, that's another meteor strike.
That is what I was talking about. Yes, they think that actually would have gone right through to the core. They think that this was massive. I mean, the crater is almost as wide as it's probably 50% the width of Ontario. This is a massive crater, but this would have happened something along the lines of 2.5. I think it's 2.5, 3 billion years ago. The Earth was very, very young at that time. Probably still wasn't anyway. But yes, they think that is why we have the iron deposits and the nickel and the nickel rich find that there is likely related to that.
We've had somebody come in the lecture about the meteorite found in Wisconsin.
Yeah.
Do you have
Mifflin.
anything? Or
I have not. So
is there stuff around? Or, I mean, obviously, it's been a long time.
10 years ago. Wait, which meteor are you talking about? I'm sorry.
There's a professor at University of Wisconsin River Falls, and he found some rocks that were vertical. Remember the name? Anyhow, it's like 2 or 3 miles around.
Oh, that was Cordua's talk about the rock elm.
Rock elm disturbance.
Rock elm
Oh, interesting. I'm not familiar, so I'm not familiar with that.
There's a little park down there you can do outside of Ellsworth.
Ah.
They used to do,
Yeah,
when I went to see it, they were mining, looking for gold and for.
Sure.
And they
They
found
no,
a
this
found a
looks
crater, they
Wisconsin.
found shock force in the middle.
Okay,
So.
interesting. So there probably was an impact, but probably a long time ago.
Yeah.
Ordination.
Yeah, like it was tropic, that part of the continent was down like by the equator.
Ah, crazy stuff. Yes, sir.
There's one in Inderbrook Heights too, but you're gonna have to dig.
Yeah.
Yeah.
Rift valleys, could they be meteorite?
I think the Rift Valleys are more related to plate tectonics, but I'm not a.
Could this contribute to
That's a great question. I don't have any idea. I suppose theoretically it could if it's big enough. Yeah.
Oh, what about diamond? You think diamond deposits in Canada? Any of those?
Diamond deposits in Canada.
Oh, there's a big amount. Yeah, they have a talk on it.
See, I don't terrestrial stuff. This is outside my wheelhouse. I really don't. Meteorite stuff. I have not heard of that, so I can't speak.
So there would be meteorite.
Well, not that I know of. I know that we have, so South America and Africa have sort of mirrored mines and deposits of carbonado diamonds, which is what we use in industry. And those have been operating for as long as we've had industry. And we believe those are extraterrestrial. But that's the only deposit. They think it was actually one deposit that, as the plates separated, just divided apart. So they think it's the same material that probably was deposited by a large asteroid, hundreds of millions and billions of years ago. But that's the only one that I know of.
Assuming that they managed to get asteroid mining actually working
Yes.
in our lifetimes.
Yes.
How much space law has been written about that yet, or how much has yet to be decided by the UN?
That is a great question. I actually had the privilege here at the university to speak with the woman who is in charge of finding meteorites on Mars via the rover. And that was one of the things that she talked about. It is a brand new discipline, space law. And it is not yet even, I don't know if I'm not aware that there even is anything yet, but it is something that people are starting to talk about for that exact reason. So we'll see where it goes.
Could you talk a bit about
I can
the
talk
direction
about
you
it.
brought it and the business side of what you do and
Sure.
your company and
Absolutely. I actually had that as part of the slideshow, but it got too long, so I cut it out.
Do you have your web address on one of your slides?
Do you want me to
I
pull
don't,
it
but I
up?
have a whole bunch of business cards that you guys are welcome to take. And honestly, my website is the most abused.
Well,
It's,
the what? I would pull it up. The website doesn't.
you can pull it up. I don't
Yeah,
know.
nothing's been like.
No. So I got rid of everything before the Tucson show that was on there, and I just don't have time to put stuff back on. So I leave it basically as a catch-all. Teachers who are looking for somebody in Minnesota to do talks and other stuff like that. It's got a little bit of information about us, but nothing in terms of shopping. Most of the sales I have are people within the community who know me, call me and say, hey, do you have X, do you have Y, do you have Z, or other dealers who say, hey, I'm looking for this. So my business is primarily cutting meteorites. Cutting, prep, and preservation. So iron meteorites, as they fall, should have no chlorides in them. So chlorides are what make things rust. You hit chloride oxygen, chloride water, and boom, you have oxidation. A fresh iron meteorite, like the one I showed a video of, or a picture of early on that was still nice and brown crusted that was found in Norway on private property, that is going to be very rust resistant. Something like Alatai, or even worse, Munina Lusta from Sweden, which is 1.5 million years old and it's seen 4 ice ages, rust in a heartbeat. So I do a lot of electrolysis and reverse electrolysis to remove chlorides from irons and do the preservation. I do a lot of that work for museums and big collectors. But our primary business is cutting. So my partner, I call it my partner, we're actually separate businesses, but have worked together since the very beginning. This is his rock, and he sends me literal tons of rocks. And we started out with just a lapidary saw, and after a very short time, when you start cutting lunar meteorites that are incredibly valuable Martian meteorites, you realize that a lapidary saw isn't ideal because your losses are so high. And so we went in halvesies on a diamond wire saw, which uses a very, very fine, in this case it was 0.12 millimeters, a wire that runs on a reciprocating motor back and forth, 40 yards at a time, and slowly works its way down to the wire. So you have minimal loss, but it's a very slow cut. And that's what we used. Most of what you see up here was cut with those. So as we grew, which happened very, very quickly, I had to buy larger wire saws and larger wire saws, and we just got one. I deleted the. Can you find pictures of divorce? So I ordered. We finally got one big enough to cut really big. It's big, big. This larger than this, which is very rare. They're hard to. They're incredibly expensive, more than my house in most cases, and very difficult to find. You just plug your ears. So we ordered, myself and Mark, the guy who owns the big stuff. We went halvesies and ordered this massive saw. And I'll be honest, this was the first time in my life I went and I looked at it. I went, "Oh my God, what have I done?" The guy pulled up at 8 o'clock in the evening. He was supposed to be there at 10 in the morning. We lived on what used to be a dirt road, just a very narrow, newly paved road. And he comes walking down, and he's like, "Hey, do you have a forklift?" And I said, "No, I don't have anything here. You were supposed to have a look. These guys have delivered all of my saws, so they usually come prepared." He's like, "Well, I don't even have a pallet jack." And I was like, "Oh, well." He said, "Why don't you come and take a look at it? I'm hoping she'll find pictures." So I said, "Sure, let's go take a look." So we walked up, and it's wintertime. And he opens up the back of the truck, and my heart dropped to the floor. This thing, the front crate was about 10 feet tall, 8 feet wide by it was 8 feet square. And behind it was another crate that was 4 feet tall and probably 10 feet by 10 feet. And then off to the side of that was the control panel in yet another box that was 4.5 feet by 4 feet.
Looked like a refrigerator.
And I was just like, "Oh my God, what are we going to do? How much does it weigh?" It was only supposed to weigh 2,000 pounds. So he said, "Oh no, this weighs more than 2,000 pounds." I was like, "Oh." So I call up a buddy of mine who lives down the road. He came up. He's a contractor, so he had the next morning he came with a bobcat and his forks. The bobcat is like, "All right, if I get ejected, get out of the way." So we had to tie 2 toe straps and slowly pull this thing out. And when it finally got out, it would thump down the thing, and the butt end of the forklift went straight up in the air. He's waving at me. It was very heavy, and it was massive. So he dragged it down our road on the ice, thankfully, and it's sitting outside of our garage, and it's higher than our roof. And my son, who works for me, is standing outside the box, and that's when my wife got to see it for the first time.
And I thankfully was out of town for all of it beforehand.
Yeah, that's true. You were on vacation.
That was
it's a good thing. Anyway, the saw was promptly named Divorce, and Divorce is now set up and cutting. But they're very big. I apologize. I had that as part of the thing, but it got too long, so I took it out. Anyway, that's my story. So we started very small, and just over the years have grown and sort of taken over the global market. So now I do cutting for museums all over the world. I do cutting for huge collectors all over the world. We do a lot of work for Steve Jurvetson, who was one of the co-founders of Tesla. He's only worth $150 billion, and he's the cheapest guy out there, but that's neither here nor there. He loves meteorites. He absolutely loves meteorites. So anyway, we work with all kinds of institutions, museums, and people, and it's been just incredible ride.
So how long a lifetime for the diamond wire?
Highly variable, depending on thickness and what you're cutting. Usually, so the Divorce uses 500 meters in a roll. So it's a motor that spins, 500 meters, wraps, unwraps, wraps, unwraps. On an iron meteorite, which is what I use it for cutting almost exclusively, like this one, it'll go about 3 days without having to change it. And if it breaks, sometimes it's just a fluke and you can fix it. Sometimes you have to change it out. Sure. I order wire 40 kilometers at a time out of China.
Wow.
Yeah. I run 4 saws, 24/7, 365.
Good question. He's very busy.
What's that?
Your FedEx guy must be.
Oh, my FedEx.
You can only imagine. We get a lot of packages.
We get a few that probably should. Yeah, it's always fun.
Right.
I need to get a forklift. We need a bigger shop.
We have friends with bobcats.
We need a bigger shop. Anybody else? Or, all right.
Let's wrap her up then for tonight. But if you'd like to come on down.
Okay, so This is a slice of what's called a Mount Dooley meteorite. This is an Australian iron meteorite. Iron meteorites all have a unique pattern, a fingerprint, so to speak, based on how quickly or slowly they cool. You can see this one is what we call an anomalous pattern because they're different size crystals, which doesn't fit into any of the known patterns that we have. So this is what we call an IC. It's an ungrouped, basically, pattern. One of the most sought after, very little of this material available. So this is Campo del Cielo from Argentina, another large iron meteorite. Historically, this was thought to be one of the largest finds on the planet. That has now been usurped by a Chinese meteorite, but Campo del Cielo is another likely witness fall 4,000 to 5,000 years ago, and the indigenous peoples used that for tools long before the conquistadors arrived in 1576. Hundreds of tons.
Similar kind of thing.
Yeah, I mean, there was a time when you could buy this stuff. They were giving it away. They literally started breaking it up into crystals. They put it in liquid nitrogen, hit it with a hammer, and it breaks into the natural crystalline structure that you see in little crystals. And they give it away because they just couldn't get rid of enough. Now it actually is so. Number one, in 2007, they outlawed the export of the meteorite. So that slowed. There's still a lot of it down there, but that dramatically slowed how much came out of the market. And now it's all been chewed up for slices and jewelry and all the other stuff. So now it's becoming rare, and suddenly this piece that I've kept because it's so shapely is valuable. So hopefully in another 10, 15 years it will be even more valuable. Yeah, right, exactly. That's exactly right. This is a large eucrite. This was a massive fall. They found over 6 tons of this rock in northwest Africa. It's a recent fall. This is an impact melt, and if you look at it, you can see there's vesicles, which are very rare. There's also melt veins, and you see there's different types of material in here. So this is unmelted. This is all melted, although this is this is heavily melted. So when we cut this open, this will be one of the rare meteorites that has vesicles, holes inside from gases that expanded during this massive explosion in space when 2 asteroids collided together. Where do you want
This is all meteorite.
Almost 100% meteorite. Well, impact melts are 2 asteroids colliding. They're nothing to do with terrestrial. Nope. These are just a variety of other meteorites. This is Samchan from Russia, found in 1967. It's a palisite, but this is the olivine crystals are very few and far between in this particular slice, but you see it has a beautiful pattern. And I have more of that down at the other end of the table. This is also a palisite, but it's a siderite. It's one of only 2 found where there was very little olivine and mostly iron. It's got a Schreibersite vein in the center, which is a diamond-rich iron oxide, basically, and a few olivine crystals around the edges. I give up. Sakota-Lin, 1947 witness fall in Russia, with a troilite inclusion in the middle. Very wide banding pattern on that because it would have cooled very slowly. Initially, yes. Now I deal directly with people who go out and find it. This is Munita lusa. This is a Swedish find. About 1.5 million years on the ground. Has incredibly fine octahedral pattern and is highly sought after by jewelry makers. This is Alatai, a Chinese meteorite that has a wide variability in patterns among the pieces. These are the same meteorite, even though you wouldn't know it by looking at them. The mass was so huge, parts of it flew closer to the sun, recrystallized, parts of it stayed in their original form, so you see different patterns within the same meteorite. The Campo del Cielo that we started with, the big hole piece, this is what it looks like if you cut it, and you can see the pattern inside it. Yeah, this is also Campo del Cielo. We make spheres. Again, it's a relatively inexpensive iron, so we get to do fun things with it. Yep, correct. Gibeon, a Namibian fall. This is one of the most famous meteorites because it is so popular by jewelers and collectors because it's very rust resistant. Fell in the desert, has a phenomenal pattern, and so it's very easy to use to make rings and other jewelry, and you don't have to worry about it rusting. Wedding rings, huge use of this. Right now the Chinese are buying this so fast, it's almost unavailable. This is a relatively new African fall. This one doesn't seem to have a pattern unless you tilt it, and then you can see there are some different crystals. This would have been a very slow cooling, very high nickel meteorite. So the pattern is extremely large and would have been very slow forming.
I think polished or varnished.
Both. I coat them just to prevent rust if they're not. I coat every because I do a lot of talks. People touch them, so your hands of salt. So I coat everything just so it's safe.
Just stop the rust or not necessarily?
Yeah, it's to stop rust. Yep. This is the only meteorite we know that has a changing pattern from Northwest Africa in the same meteorite. These are supposed to cool at 1 degree C every 10,000 years or slower in the core, a molten core. How do you get the difference in patterns from cooling speed from one side to the other? It's a complete mystery, and this is the only meteorite ever found that has such a distinct difference called, I don't remember. NWA 14131 is the number, but it has a nickname that I don't recall off the top of my head.
I used to think my dad had 4.
Let's see. Another Australian meteorite with a great etch. This is Nantan, an ancient Chinese meteorite that is full of carbon inclusions, lots of carbon, lots of troilite, and a little bit of schreibersite. But this is a massive find that tends to rust. This is another example of the whole piece. It's been on the ground a long time, so it's a very rust-prone meteorite. So people don't usually like to do much with it, but if you stabilize it, which I did with this piece, they're absolutely stunning and for very low cost. So it's a beautiful meteorite to have if you get a good one. What's that?
How do you stabilize it?
Reverse electrolysis. Months and months and months. Another chondrite. This one is just classified. It's a rare type where it has multiple types of chondrite in one piece. So this would have mashed together at the very beginning of the solar system. You actually have carbonaceous clasts. You have low iron areas out here, and then there's other areas that are high iron with different grades of degradation on the chondrules. So this is multiple meteorites, not melted together, but accreted together over time. Extremely rare. One of only 2. And I was fortunate enough to actually bring that to science. This is an impact melt called Tacetid 004. You can see the melt veins, the light colored, and the asteroid that's unmelted on the sides. These are the result of massive collisions between 2 asteroids in space that instantaneously release enough heat to actually melt the 2 pieces together, melts the iron in the center to create those beautiful blends. This is Lansing. It's a witness fault from 2018. Abapanu. This was also tracked before it hit the atmosphere, only for a couple seconds, but we saw it before it hit the atmosphere. This is off the biggest piece ever found. It was 23 kilos, and it shows a great job of the different clasts inside of this, as well as the big chondrules. One of the most unique pieces out there, and will be one of the most studied. This is just a type 3 chondrite. You can see the large circles. Those are chondrules. Again, those are leftovers from the very start of the solar system that never smacked into other rocks, never turned into melts, never turned into a planet. These are just literal pristine leftovers preserved in a rock that's 4.5 billion years old. These are eucrite impact melts, so these are achondrites. So they don't have chondrules. These would have been from a differentiated body. Asteroid 4 Vesta is what we believe. And these were, again, impact melted. So these would have been hit two meteorites or meteors smacking together with enough force that the heat released melted the 2 bodies together. This is a palisite, and this is Sercho from Kenya, recently found in 2016, although this is an ancient fall. The rocks were so large, some of them, and so well worn, because for the last 10,000 years, native tribes in Kenya actually used them, their kids used them to slide down. They were the only thing in a flat desert they had to play on, and they had slides going down the sides of some of the bigger ones. So that's Sercho, that's a palisite. Maybe came from a core mantle boundary of another planet, maybe came from a collision between an iron and another asteroid, we aren't really sure. This one? Sercho?
Yeah, maybe just so shiny.
Yeah, it's like 50-50. This is same chin as well. This is unetched, but this is the Russian palisite. This is where you can see some of the olivine on the sides as well as the iron in the middle. This is
I got the whole room in it now.
This is another same.
On the top of Baldy.
There you right. No kidding.
Go around circle.
I
I
haven't.
ask, can't you? Oh yeah.
So Simchan, again, these are both Simchan. This has very pristine olivine. You can actually, let's see if you can see my hands go through there. You can read through those gems. Those are peridot, called olivine in space, so space gems. This is a brand new mesosiderite that we're just classifying from Northwest Africa.
Yeah.
So again, this would have been either from an impact or the core mantle boundary of a defunct planetary
Railroad
asteroid.
tracks, not meteorites.
And I'm sliding these over. So
Gemstones.
this Kenyan palisite, Seracho, this is what they look like before I cut them. So this is an uncut Seracho palisite. When it's opened up, will look very similar to this.
Can't afford not to either.
Oh, no, I can definitely afford not to.
And then if you want, this is just my Minnesota meteorite collection. I see.
Where's High Island from?
Well, High Island is the one I was trying to think of. That's the one from the Lilienthals.
Oh, okay.
And I'm not 100%, I don't remember.
So these are all slices of one.
These are all slices, correct. This is the one Calvin owns. So this is High Island Creek. This is a big flat disc iron meteorite that was oriented. So the sides were melted back, so it held its course during at least part of its entry through the atmosphere.
Can you let you cut it?
Calvin actually had it cut first when he found it to confirm what it was. And then he let me cut one of the pieces that was cut into thinner sections to sell and donate to other institutions. Fisher is another. These are all fine. So Fisher is a find, just an ordinary chondrite, but this was witnessed I want to say in the neighborhood of 1903, early 1900s. So this was received from the University of Minnesota as payment for helping to refinish their meteorites. Hardwick, also from Minnesota, found 1937, as you can see. Relatively small stone, very, very hard to get, almost 100% in institution. All of these are very hard to get, but this one is almost 100% institutional. Arlington is a sad story. This is a Minnesota iron as well. Unfortunately, virtually all of Arlington was cut decades ago when meteorites were first being studied, and they destroyed it. They soaked it in acid. They did all kinds of terrible things to it. So there's very little Arlington available out there. This was just a small piece that I actually had to get from a Chinese collector who got it from a United States institution. So it's a very hard iron to find. There's very, very little of it out there. And then last but not least, we have Euclid, Minnesota, which is named after the town it was found from. Farmer found that laying out in a field while he was walking out in the springtime. Thought it felt heavy, thought he saw some iron, so he brought it in, had it cut. Lo and behold, it was indeed a meteorite.